Okay, so you've shared some really thought-provoking articles about, what's actually fueling this whole electric vehicle revolution.
Hmm.
And instead of listeners getting lost in like all the technical details, we thought we'd just dive in and pull out the essential insights, the stuff you really need to know.
Sounds good. It's a complex picture.
Totally. We're talking about that rising demand for specific minerals. You often hear them called rare earths, but also things like lithium, cobalt, nickel, copper.
Right. The key ingredients.
Exactly. And it's all driven by the boom in EVs and solar panels,
Yeah,
too.
those markets are exploding.
But what's really interesting, I think, is that your sources also dig into potential alternatives to these materials.
That's crucial, yeah. Lots of innovation happening there.
So our mission today basically is to give everyone a clear, sort of concise understanding of where this market is right now, the challenges, definitely,
Yeah, there are challenges.
and the solutions people are looking at sound good.
Absolutely. Let's
Mm.
do it. The speed this is all moving at is, well, it's pretty remarkable.
How fast are we talking?
Well, the market for these minerals, the ones powering cleaner energy, it's actually doubled. Doubled in just the last 5 years.
Wow, doubled. Okay.
Yeah. And if you look at specifics, say between 2017 and 2022, the International Energy Agency, the IEA, they reported cobalt demand surged 70%.
70%.
And nickel was up 40%. So this isn't just like slow, steady growth. It's a real jump.
Okay, so definitely not a slow burn. It's rapid acceleration. And this isn't some tiny niche market anymore, is it?
Not at all. Back in 2022, the value hit $320 billion.
320 billion.
Yep. And all the projections, they just point upwards. Continued growth, especially somewhere like Europe.
Europe specifically.
Yeah, one of your sources pointed out that Europe's expected need for battery raw materials, just for cars alone, is forecast to be 200 times higher than what they used just the previous year.
200 times. That's hard to even picture. That really highlights the scale of the challenge, doesn't it?
It absolutely does. And, if we think about the bigger picture, the environmental side of things, a really key factor driving this demand, something Transport and Environment flagged and the IEA echoed.
What's that?
It's the growing size of EV batteries.
Oh.
Their research shows the average battery size is actually increasing faster than the rate of EV sales themselves.
Right, so it's not just more EVs, it's bigger EVs. Kind of like the trend we saw with regular cars, everyone wanting SUVs.
Exactly like that. The preference for larger vehicles seems to be carrying over. Electric SUVs are getting really popular.
And your source had some numbers on that.
Yeah, pretty compelling data from France, Germany, the UK back in 2022. On average, electric SUVs weighed 1.5 times more than smaller electric cars.
Okay, 1.5 times. And that means more steel, more aluminum, plastic.
All of that. But the battery difference is even starker.
How much bigger?
Typically, the SUV batteries were twice as large as the ones in smaller EVs.
Twice the size. So that translates directly to needing more of those critical minerals we were just talking about.
Roughly 75% more, yeah. And here's the kicker, the ripple effect.
Uh-huh.
The CO2 emissions tied to getting those materials out of the ground, processing them, making the batteries, assembling these bigger vehicles, it can be over 70% higher.
Wow. Okay, so bigger isn't automatically greener than when you factor in the whole life cycle and the materials?
Exactly. The IEA really stresses the need to address these impacts tied to battery size. It's a critical point.
That is a crucial distinction. Okay, let's unpack this term rare earths. It sounds, exotic, maybe even scarce. What exactly are we talking about?
Right, it's a bit of a misnomer, actually. The term rare earths covers a group of 17 elements on the periodic table. Things like scandium, neodymium, lutetium, cerium were mentioned in the source.
Okay.
But despite the name, they aren't actually geologically rare. They're quite abundant in the Earth's crust.
So why rare then?
The challenge is that they're very dispersed. They're not usually found in concentrated deposits like, say, copper or iron ore. So extracting them in economically viable amounts is difficult and often environmentally problematic.
Gotcha. Difficult to concentrate. And what makes them so important for EVs?
They have these unique magnetic and conductive properties. Right now, their main use in EVs is in the really powerful permanent magnets that make the motors work in battery electric vehicles, BEVs.
Okay, the motors. But one of the sources you sent really highlighted a potential issue here, China's role in the market.
Yeah, that's a huge factor. China has, quite strategically over decades, built up a dominant position. They handle about 63% of the world's rare earths extraction,
63%?
and an even more impressive 85% of the refining,
Yeah.
turning the raw stuff into usable materials.
85% of refining, wow.
Plus, they hold massive reserves, something like 44 million tons.
So what are the concerns there? Is it just supply?
It's multi-layered. Firstly, there are environmental concerns. The extraction and refining processes they often use can involve pretty toxic chemicals, leading to pollution.
Okay, environmental impact.
And secondly, yeah, it's the geopolitical risk. Relying so heavily on one single country for materials that are critical for, the green transition, that creates a vulnerability.
Makes sense. Pricing power, potential supply disruptions.
Exactly. It could be used as leverage. It's a significant bottleneck for countries wanting to ramp up EV production quickly.
Right, a classic supply chain weak spot. The source mentioned other countries have reserves, like Vietnam, Brazil. The U.S. has some too.
Yeah, the U.S. has about 1.5 million tons. But despite that, they still import a lot from China.
Hmm.
And there was that mention of a big deposit found in Sweden, which is good news for Europe potentially, but getting that to large-scale production,
Yeah.
that takes time. Years, likely.
Okay. So given this reliance, these environmental issues, the geopolitical stuff,
Yeah.
it makes total sense that car makers are trying to find ways around using rare earths, right?
Absolutely. And that's where the innovation piece gets really interesting.
Like what?
Well, look at Tesla. They've made a pretty public commitment to cut down and eventually eliminate rare earths in their motors.
Really? Eliminate them entirely.
That's the goal. They've apparently already cut usage by 25% in the Model 3 and Model Y since 2017. And they're aiming for a totally rare, earth-free version of their permanent magnet synchronous motor, the PMS motor.
Do they have a timeline for that?
Not that was mentioned in the sources, no.
Yeah.
But
Right.
it clearly shows their strategic direction. Less reliance is key for them.
That's a pretty big statement from a player like Tesla. Are others doing similar things?
Oh yeah, they're definitely not alone. Your sources mentioned several others. Toyota and Volkswagen are also working on just reducing the rare earth content.
Okay. Reduction.
And BMW and Nissan have apparently managed to get rid of rare earths completely in some specific models already.
Wow. Okay. So some are already there on certain vehicles. What about totally different technologies? Are they exploring those too?
Yes, absolutely. Beyond just using less, there are some really interesting alternative approaches popping up.
Like magnets made of different stuff.
Exactly. GM, for instance, is using ferrite magnets in some applications.
Yeah.
That's more established technology, uses common materials like iron, barium, strontium,
Stuff that's easier to get.
much easier, and a more secure supply chain, less environmental baggage typically. Maybe not quite the same power density in all cases, but definitely viable.
Okay. What else?
Then you've got Renault working with Valeo and Siemens. They're developing something called externally excited synchronous motors, EESMs.
ESM. What's different there?
They use copper wiring instead of rare earth permanent magnets. Basically, they use electrical coils to create the magnetic field when needed.
Ah, so no permanent magnet needed.
Right. It gives more control and completely avoids rare earths in that part. They're planning to start production in 2027 at Renault's plant in Cléon.
2027. Okay. Not too far off. Any other contenders?
Yeah, a couple more mentioned. There's this company called Niron Magnetics getting backing from Stellantis and GM, actually developing nitride-based magnets, a totally different chemistry.
Nitride-based. Interesting.
And Vitesco Technologies apparently presented a rare earth-free ESM design that they think might even offer longer driving range.
Longer range without rare earth. That sounds promising.
It does. So yeah, it feels like a real race to innovate, driven by supply chain security, cost, and environmental responsibility.
Definitely sounds like it. Now, we touched on this earlier, but let's circle back to the idea of just using less stuff overall. That transport and environment source had some thoughts on reducing demand, right?
They did, yeah. Their approach is kind of multi-pronged.
Okay.
First, they really push for a shift towards smaller, more affordable entry-level electric cars.
Right.
Basic logic. Smaller cars, smaller batteries, less mineral demand.
Makes sense. Fewer SUVs, more compacts.
Essentially. Second, they highlight chemical innovation in the batteries themselves, finding and scaling up new chemistries that don't rely so much on cobalt, nickel, or even lithium maybe down the line.
New recipes for batteries.
Kind of, yeah. And third, and this is maybe the bigger societal shift, they stress the need to just reduce our overall reliance on private cars, more public transport, walking, cycling.
Right. Fewer car trips overall means less demand for cars, period.
Exactly. And T&E put some numbers on this. They estimate that if we prioritize smaller, affordable EVs, combined with battery innovation and reducing car use, we could potentially slash demand for those critical metals, lithium, nickel, cobalt, manganese, by somewhere between 36% and 49%.
36 to 49%, that's huge potential
It
saving.
really is.
But playing devil's advocate, consumers, especially in places like the US and Europe, have historically liked bigger vehicles.
hmm
Is it realistic to expect that trend to just reverse? Are there policies that could actually nudge people that way?
That's a fair question. And T&E does propose specific policy tools, things like tax breaks or incentives for making and buying those smaller, affordable EVs.
Okay, financial carrots.
Yeah. And at the EU level, they suggest maybe efficiency standards for batteries, not just cars, and maybe even rules requiring automakers to produce a certain number of entry-level
They're
models.
mandates. Okay, interesting.
They also point out that smaller EVs are actually ideal candidates for some of these newer, less resource-intensive battery chemistries we mentioned,
Ah, like which ones?
like lithium iron phosphate, LFP batteries, which are already gaining traction.
Right, I've heard of those. Less cobalt, less nickel.
Exactly. And also sodium-ion neon batteries, which avoid lithium altogether. These use much more abundant elements. Just adopting these chemistries could cut demand by another 20% potentially.
So smaller cars plus better batteries equals significant savings.
That's the idea. And then if you add promoting alternatives to driving better public transport, safer bike lanes, they figured that could shave off another 7 to 9% of demand.
So it's not just about tech breakthroughs, it's also about system change, policy, maybe even cultural shifts in how we view transportation.
Definitely a mix of all those things.
Okay, one last piece of this puzzle that came up in the sources. Recycling. How big a role can that play?
Recycling is absolutely critical. It's
Yeah.
key to making the whole thing more sustainable and creating a more secure supply chain long term.
Makes sense, closing the loop.
Exactly. Your source mentioned Nissan is working actively with Waseda University in Japan. They're developing ways to efficiently get those rare earths back out of old electric car motors when the cars reach end of life.
Recovering them from the motor specifically.
Yeah, and their goal is to have this working on a large scale by the middle of this decade. So, pretty soon.
That's great news. Being able to reuse those valuable materials would cut down on mining, obviously, but also waste.
Precisely. It helps build that circular economy we need, especially for materials that are energy intensive or problematic to extract initially.
That really sounds like a vital step. It definitely feels like a truly sustainable shift to EVs isn't going to come from just one silver bullet then.
Oh, definitely not.
It's a combination of everything we've talked about. Finding and scaling up alternative materials for motors and batteries, reducing the overall demand by shifting towards smaller vehicles and maybe different transport modes,
Right.
developing those more efficient, less resource-hungry battery chemistries like LFP and sodium ion,
Yeah, of
and finally building out a really robust and effective recycling system to capture materials at the end.
Exactly. It's a multifaceted challenge, no doubt, but also a lot of interesting solutions being worked on.
So you can really see the whole transition to electric vehicles is, well, it's a lot more complex than just swapping gasoline for electricity, isn't it?
Far more complex.
It forces this huge shift in material demand, supply chains, and it really spurs on technological innovation across the board. Getting a handle on these underlying factors is, I think, really key to understanding the bigger picture of sustainable transport.
Couldn't agree more.
So, thinking about everything we've discussed, the big push for electrification, all these different strategies to cut reliance on critical minerals, what do you think might be the biggest game changer in the long run? What will really make electric mobility truly sustainable? Is it going to be those tech breakthroughs in batteries and motors?
Possibly.
Or maybe a real shift in what we as consumers want moving towards smaller, more efficient cars? Or is it getting that recycling infrastructure truly up and running globally?
That's the multi-billion-dollar question, isn't it? Probably a bit of all three working together.
Yeah, maybe it has to be. Well, hopefully this deep dive gave everyone some insight into the materials powering our electric future. If you found it useful, please do give it a like.